We will now look at the holographic architecture using semantic technologies, and more specifically at the norm engine. And to do so, we can welcome back Flores Bakker, who was with us already yesterday afternoon, for those of you who were joining our session. And Flores is Enterprise Architect at the Ministry of Finances in the Netherlands. Good afternoon, Flores.
Good afternoon. Thank you very much for your introduction. Indeed, second time here. Again, about the holographic architecture, and now a different part of the holographic architecture, the norm engine. I will explain a little bit about the holographic architecture in a minute, and then move on to the norm engine. And just I wanted to start with why the holographic architecture in the first place. So I'm an enterprise architect for the Dutch Ministry of Finance. We have a lot of information artifacts. We have a lot of application software, algorithms. We have a lot of laws, information products. So that is a giant, big collection of information. And how are we going to manage that information? That's pretty difficult. So the holographic architecture is a architecture that tries to solve that puzzle. And basically it amounts to everything is information. So let's move on. Let's see what are the principles behind it. So one principle is the importance of information. It's pretty much obvious, especially at the endorsed 2023 conference, that information is central to it all. But information in the broadest sense of the word. So not only your usual artifacts like a law or perhaps a dashboard or some data set. No, anything that we need to provide our government service. So that means also algorithms is just as well a data artifact, just rendered in some programming language, but yet still information on its own that we need to manage and to maintain. So that is the importance of information. Anything that we need to service the government and the society. And then to do so, we need norms. And what are norms? That's actually a specific term from a domain of field in the scientific area where laws and other forms of norms are studied. So examples are indeed the budget laws, the GDPR, but also business contracts. Basically anything where it says, thou shalt do this, or I must do this. And norms describe valid behavior. So when is behavior seen as valid, as compliant? So what preconditions, what requirements do we state for that behavior? And how does that behavior change the state of affairs, the world wherein that behavior is affected? So if you look at nowadays digitalisation, you can see basically that we are not very good in handling norms. We basically have software from different suppliers, and then we hope, for instance, by doing audits and compliance checking and assessments, that it is conforming to what is said in the law. I want to move on a little bit, and I want to directly execute the laws and contracts by modeling those contracts and laws. So we need a norm engine. So those two principles, when we see them as consequences for digitalization, we need to be able to describe any information. Hey, what language is there that can help us to describe any information? That'll be RDF. And how can we handle any norm, any law, the GDPR or a budget law or a purchase agreement? It doesn't matter what kind of norm, but we need a norm engine, right? So we came up with a prototype of a norm engine. It's going to be published hopefully soon in a journal. We still are waiting validation of that, so it is very fresh and hot. And the norm engine is 100% based on semantic compliant technologies. There's no other technology involved in that. So how does that look? So everything is information. So we are storing that in the information plane, right? So that can mean we can have transactions. That can mean we have regulations. That can mean we have applications defined in the information plane using solely RDF. And we need different vocabularies for that. For instance, shackle. As you can see on the application dimension, we can use shackle to to store, for instance, algorithms and to execute even algorithms. And we can also use the HTML vocabulary. I described that yesterday in the other session. And with the HTML vocabulary, we can model any HTML document in RDF and then generate the relevant HTML document itself. That gives us a lot of control over that HTML document, a lot of knowledge about its provenance, certification, context and semantics about the workings of that HTML document. For instance, a GUI of an application, a website, or a budget bill. Moving on to the right, we see the normative dimension. So that means that with the ontology of Flint, which is where the paper is about, we can model any law, any contract, any ethical rule, any cultural norm. It doesn't matter as long as it is a norm, as long as it is stated, thou shalt do this or you shall do that, right? So, and then by executing the steps in the law or in the contract or other form of norm, only then we speak about processes. The processes are derived from following the footsteps as stipulated in the law. So how does that look when we zoom in? A norm engine, let's look at the picture on the right. So we have on the top of the picture, we have a normative language. We can capture any law using Flint. Flint is designed to structure any norm. Then we have a lot of normative sources. So I mentioned them already. Laws, the GDPR, the budget law, purchase agreements, some ethical rule, you name it. And we specify that source in the language of Flint, right? And then we make a difference between acts and facts. So acts are the behavior itself, and the facts describe the state of the world in which that act can take place. And the acts are descriptions of behavior together with the preconditions and the postconditions under which they are deemed valid. And we are storing this all as RDF using a combination of OWL and SHACL. And then we have some event going on. Someone is truly doing a purchase agreement, or someone at the Ministry of Finance is creating a budget. And then we would like to validate that behavior. So we have to instantiate that scenario to that law, right? And then we can check things. So let's this is fairly abstract. Let's have some fun. Let's play a game. And I'll switch to this. Let's play the game of tic-tac-toe. It's fairly known to everyone. It's the microcosmos of laws. It has 4 game rules. And we'll start the game with a scenario. Player X starts a session of tic-tac-toe, right? So this is all RDF. Now we are offering the scenario to the SHACL engine. It says it conforms true. I hope you can see it on the right, conforms true. And let's have a look at what it did. And let me see here. Yeah, so here we can see that player X starts a game of tic-tac-toe. This is the original scenario that we offered to the engine. It says the action is putting a mark in the square for the game done by player X. It uses some modeling of the world around this action. It uses object square 5, so it's the middle square, and it places symbol X there. And then we can see the recipient, that is the opponent, that is player O. And we can see that this original scenario has now been invalidated by the behavior done by player X. So the computer said, hey, this is a valid behavior. I'm going to create a post condition of the world. There's a new state of affairs. So let's see how that turns out. And then we can see here. Here you can see the post scenario. And we can say, hey, this scenario, this was actually derived from this law, a SHACL shape. So we can pinpoint exactly what article was used in the law, or game rule in this case. And we can also say this was generated by some activity, in this case, player X opening the game. And then we can see a description of the state of affairs, how that has changed. So we can see here the game board with all the squares of the game board. And when we zoom in on the game board, we can see indeed square 5 has now been marked with symbol X. So now we have created a valid new state of affairs. And now let us look what happens when someone cheats. So player O takes a turn in a game of tic-tac-toe, but does not have to turn. So let us see what happens there. We run it again, and then we get a constraint violation. We can see on the right here, we can see pinpointed at the exact article that is touched, that is violated. And we can see also that which event it is. It is player X takes turn in the game of tic-tac-toe. And we can see that the value not player O is not allowed. The current move is not allowed as the player does not have the turn. So we can handle compliant behavior and we can handle violations of non-compliance. And this is all captured in OWL and Shackle. And the nice thing about this is it is not specified to a certain domain. You can reuse this engine for any domain of law. I mean, it is easy to use OWL and Shackle to immediately model your domain of expertise. It's easy to do so, but you don't want that. You want an infrastructure that can handle any norm, whether it's the GDPR or the budget bill, a purchase agreement or an ethical rule, and you want it to be a generic norm engine. So, and we are offering that with a sound theoretical background done by University of Amsterdam and TNO, our partner when it comes to scientific applications. So, and this is the prototype that I wanted to show to you, just the power of semantic technology in how we can add to a more democratic and transparent way of handling norms, be it laws or contracts or anything else.
Thank you very much, Flores. Thank you. And that was quite an innovative way of playing tic-tac-toe, I must say. But thanks a lot. And we have a question here for you. The data follows the model, but how will the institution capture the information to be stored at every level in the hierarchy?
Let me see if I understand this.
Do you want me to repeat?
I'm not sure if this is really, I don't see it as a problem. So I don't think I understand fully the question. So when we are dealing with norms, we have models of the laws and we need scenarios that are instantiated into those norms. That is basically all that you need. So it can be, you can use a financial system that instantiates the behavior into the laws, and we can even use OWL reasoning to deduce what laws would be relevant for this case. We don't need to explicitly state that even. So I'm not sure if I really understand the question, but I don't think it is that much of a problem. It's basically what laws are you using and what is your scenario? Offer me your scenario.
Okay. Yeah, I think the core of the question is really how will the institution capture the information? Which is then to be stored at every level.
Yeah, and that depends, of course, on the use case. For instance, the budget bill. When we create budgets, they are officially a law. That is how it works in the Netherlands. And we have budget systems offering the budget data. And then, of course, we have the budget laws that we can model in this prototype, and we combine them. And we need, of course, the budget data to be also in RDF. That's a requirement. And then we can, because we have modeled the laws, and so that means we can reason about that budget data. We can use the budget data as long as it is in RDF. That's the only requirement, basically.
Thank you very much. Thanks for being with us again today. And we wish you a very nice evening. Bye-bye, Flores.
Okay, thank you very much. Bye-bye.